I'm going to start off with just talking a bit about BFR and kind of how we got to this point. So the purpose of SpaceX, the reason for creating SpaceX was to accelerate the advent of humanity becoming a spacefaring civilization, to help advance rocket technology to the point where we could potentially become a multi-planet species and a true spacefaring civilization. So, as we consider sort of the fossil record, the history of civilization, it's important to bear in mind, like, there could be some natural event or some man-made event that ends civilization as we know it, or in life as we know it. And so it's important that we try to become a multi-planet civilization, extend life beyond Earth, and to do so as quickly as we can. That window of opportunity may be open for a long time, or it may be open for a short time, but we should not assume that it is open for a long time. We should take action and become a multi-planet civilization as soon as possible. And that's kind of like the defensive reason. I do want to emphasize it's multi-planetary, not single planet, but somewhere else. We want to become a multi-planet civilization, have life on Mars, Moon, maybe Venus, the moons Jupiter, throughout the solar system, and then ultimately extend life beyond the solar system to other star systems. I think that's the future that's incredibly exciting. I think that's the future that we want. And there's so many things that make people sad or depressed about the future, but I think becoming a spacefaring civilization is one of those things that makes you excited about the future, makes you excited to get up in the morning. Like, this is something that you can look forward to. That makes you glad to be a human being. I hope that people will see it that way. That is the intent of BFR, is to make people excited about the future. So this is sort of an illustration of what it would be like on Mars base. And I want to talk about it will show you, like, this is where we were 10 years ago. So we're almost at the 10th anniversary of SpaceX's first flight to orbit. So that was 2008. Yeah, September 2008. It's the first time we made orbit. And we'd had 3 attempts before that did not succeed. So we'd had 3 attempts to reach orbit, and then the fourth attempt reached orbit in September 2008. And if we had not reached orbit on that attempt, the SpaceX would not exist. So that was the fourth and final possibility of reaching orbit. That was a very, very tough launch emotionally. But fortunately, that launch did make it to orbit. And then not long after that, we won our first really major NASA contract, or we won the space station servicing contract, and those were 2 things that were instrumental in SpaceX's success. Then that brings us to where we were earlier this year, which is the launch of Falcon Heavy. So we went from Falcon 1 being just a little rocket that could launch only half a ton to low Earth orbit, and it had no reusability, to Falcon Heavy, which is the most powerful rocket in the world by a factor of 2, with enough payload to orbit capability to put a fully loaded 737 passengers, fuel, and luggage into orbit. And we're able to launch sort of a fun payload, which is, you know, a Tesla Roadster with sort of a Starman mannequin to Mars orbit. So we were able to launch quite a heavy payload to Mars orbit and bring the two side boosters back and land them back at Cape Canaveral. The center core didn't land successfully, but we'll be able to do that, we think, in a subsequent launch. But it was a massive change over the course of 10 years to go from just barely being able to get to orbit to the most powerful launch vehicle in the world by a factor of 2, to have full reusability of the boost stage. We've now done missions where we've launched the boost stage several times, which is like quite great. And then we've been able to refly our Dragon spacecraft. So it's an enormous change over the course of 10 years. And I think if you say like, okay, how many people predicted in 2008 that SpaceX would have done these things by 2018? I think 0. I think 0. Like, I'm not sure it's 0, but I'm not aware of anyone who had made that prediction, including me, by the way. I would have said this is unlikely. Nonetheless, in 10 years, we got from tiny rockets barely making it to orbit to the world's biggest rocket by far with reusable boost stages and sending a car to Mars. Although a lot of people don't understand like why we sent a car to Mars. Obviously that's a bit confusing. Why would you send a car to Mars? That's bizarre. But the real reason was we wanted to just have something that was fun and that people could identify with. And you know, normally when a company creates a new rocket, they like just launch like a slab of concrete or something. And I was like, well, that's pretty boring. So we wanted something that was fun and that felt like you could maybe be there. And that was like the reasoning behind the car and the astronaut in the car. That was a tribute to David Bowie and the Hitchhiker's Guide to the Galaxy and a few other things. And there's also like the Asimov Foundation series etched in glass in the glove compartment. So that's, in fact, Asimov's Foundation series is a key inspiration for SpaceX. So just an update on BFR itself. So the design, the production design of BFR is different in some important ways from what I presented about a year ago. Overall, it is 118 meters long. The payload is still similar. It's about 100 metric tons. That's 100 metric tons to, well, actually technically 100 metric tons to all the way to Mars because of orbital refueling or orbital retanking. So BFR is designed to be able to take 100 tons all the way to the surface of Mars, or to any, well, surface of Mars, maybe Ceres, but if you have a propellant depot on Mars, you're able to get from Mars to the asteroid belt to the moons of Jupiter, and kind of like planet and moon hop all the way to the outer solar system. So BFR is really intended as an interplanetary transport system that's capable of getting from Earth to anywhere in the solar system as you establish propellant depots along the way.